Hello everyone, welcome back to my YouTube channel. I am Nihar, studying in Sri Venkateswara College of Engineering and Department of CSC and Cybersecurity. Today we are going to discuss about discrete mathematical structures, rules of inference. Moving on to the introductions to rules of inference. Rules of inference are fundamental principles in logic that dictate valid argument forms. They provide a systematic way to derive conclusions from premises. Understanding these rules is essential for logical reasoning and mathematical proofs. Rules of inference and propositional logic. We always use a truth table to show that an argument form is valid. We do this by showing that whenever the premises are true, the conclusion must also be true. This can reach Tredice's approach. When an argument forms 10 different proportional variables, to use a truth table to show this argument form is valid requires 2 to the power 10 is equals to 1024. Moving on to the next topic, what is inference? Inference is a process of drawing logical conclusions from given premises. It involves reasoning from known facts to unknown truths. Different types of inference exist, including deductive and inductive reasoning. Types of inference. There are three types of inference: deductive inference, inductive inference, abductive inference. Deductive inference guarantees the truth of the conclusion if the premises are true. Inductive inference suggests a probable conclusion based on these observations. Abductive inference involves forming the best explanation from the available data. As you can see on the right hand side, there is a small chart representing the overview of the deductive reasoning, including the examples. Moving on to the next, modus ponens. Modus ponens is a rule that states if P implies Q and P is true, then Q must also be true. It is the fundamental rule in propositional logic. This rule is often used in mathematical proofs and logical arguments. Next rule, modus tollens. Modus tollens states that if P implies Q and Q is true, Q is false, then P must also be false. This rule is useful for disproving hypotheses or claims. It reinforces the idea that a true implication requires both parts to hold true. Hypothetical syllogism. Hypothetical syllogism involves a chain of implications. If P implies Q and Q implies R, then P implies R. This rule allows for the linking of multiple propositions. It highlights the transitive nature of the logical implications. Coming on to the next syllogism is the disjunctive syllogism. Disjunctive syllogism states that if P or Q is true and P is false, then Q must be true. This rule is effective in situations with mutually exclusive options. It simplifies decision making by eliminating impossible alternatives. Moving on to the next is the constructive dilemma. A constructive dilemma is an argument that rises from two conditional statements. If P implies Q and R implies S, then either Q or S must be true if P or R is true. This rule is useful for evaluating choices in logical reasoning. Rules in quantified logic. Quantified logic extends rules of inference to include universal and existence quantifiers. Universal instantiation allows for conclusions about specific instances from general statements. Extensial generalization permits inferring a general statement from specific instances. Importance of rules of inference. Rules of inference are crucial for constructing valid arguments. They help in establishing sound reasoning in mathematics and computer science. Mastering these rules enhances critical thinking and problem solving skills. These rules are applied in formal proofs, algorithm, and automating reasoning systems. They underpin many aspects of artificial intelligence, particularly in knowledge representation. Understanding these rules can improve one's ability to analyze and evaluate arguments. Conclusion. Rules of inference form the backbone of logical reasoning and argumentation. Familiarity with these rules empowers individuals to think logically and critically. By applying these principles, one can navigate complex logical structures effectively. Thank you. This was all about rules of inference. Please share the video and also like the video. Thank you.